As I was lying alone last night, trying to quiet my anxieties and negative feelings about myself, I was searching for meaning through some of the practice digital SATs that the College Board has offered us as examples of what we can expect to see on the SAT in the coming months. And something I've noticed the SAT has become increasingly obsessed with is this concept of translating graphs of whatever lines, parabolas, circles, curves. They might not even specify what exactly it is. They might just say, oh, it's f of x, and it's translated 3 units to the left, or whatever. First of all that means is it's being moved around. That's their word for moving the thing, is translating. Okay? Let's just get that out of the way. And they like to ask, they like to kind of, in their usual way, they find creative, weird ways of asking about this concept. So I found an example that's kind of like this. I just wrote this question here to represent what they're asking for these days. They give us an equation like this, 7x minus 6y equals 13. And they tell us, oh, it's translated up 5 units, which, remember, that just means we're moving it up. So we take this line and we move it up 5 units. So far, so good. And then we're going to want to find the x-intercept of the resulting graph, is the way they like to talk. So we'll deal with that later. Let's first deal with this equation up here. First thing to notice is that they did not give it to us in that wonderful, polite, beautiful, aesthetic y equals mx plus b form. Isn't that a drag that they didn't do that for us? Now, just don't freak out yet just because it's not in y equals mx plus b form, okay? We're going to take care of this. In fact, they do this a lot. They give us line equations in what is called standard form, ax plus by equals c, because they know it's going to make things just unfamiliar looking enough to make you feel like you're not equipped to do the problem. And they also know that even if you do feel equipped to do the problem looking at an equation like this, having the equation in this form is going to add a couple more steps to your process, and it's going to make it more likely that you're going to make a mistake. Or at least you'll spend more time on this one, so you'll burn through more of your minutes. Whatever. We don't have to be scared of no standard form, okay? Now, don't get me wrong. I'm freaking out too looking at this. In fact, I am just going to write out y equals mx plus b right now. Because anytime I see any question where they mention a line in the xy plane, well, I'm writing out y equals mx plus b. And then I'm going to fill in that equation with the relevant information so that I will end up with an equation in y equals mx plus b. Because that's what I want to look at as well. That's the aesthetic version of a line equation, okay? Y equals mx plus b. I can look at it, and I can see the slope right there staring me in the face. I can look at it, and I can see the y-intercept right there staring me in the face. And more relevantly for our situation in this problem, I'm going to be able to translate the line a lot more effectively and easily for me if it's in y equals mx plus b. So that's what we're going to do over here. Before we continue, just want to say I'm Coach Dalton. Welcome to the Mathochist channel. We talk math, specifically for the SAT, ACT. I like to show you the ways that I have of looking at these problems and interpreting these weird problems and sort of demystifying a lot of these concepts, because the SAT, they got tricky stuff, but they're not all that. Their tricks aren't that great, and they don't even have that many of them. So I see right through them, and I'd like to teach you how to see right through them as well. So if you have a particular math concept or question or type of SAT issue that's bugging you, feel free to leave a comment and I'll add it to my list of things to talk about. Please give this video a like, subscribe to this channel for more content like this, and feel free to email me, CoachDaltonFoster@gmail.com, if you want to apply to work with me. I also got a Mathochist subreddit, so you know, we got some stuff going on. Okay. So I could like rearrange this equation to get it into y equals mx plus b form. Like I could subtract both sides by 7x and then divide by -6. But personally, what I like to do is take advantage of those standard form shortcuts. I talked about those in another video. I'll probably link to it in the comments. Slope, if it's an ax plus by equals c form, the slope is -a over b. So that would be -7 over -6, which would become 7 over 6. So now I know that the slope is 7/6 x. And the b, the y-intercept, well, that's just going to be c over b. So in this case, it's going to be 13 over -6, so -13 over 6. So -13 over 6. Okay, and all those shortcuts are doing, the -a over b and the c over b, they're just rearranging the equation for you, basically. So you can liberate your brain from having to deal with the extra steps there and just focus on that. And now we get the real benefit of why putting it into y equals mx plus b is a good idea over here. Translated up 5 units. To go up 5 units, all I'm going to do is add 5. Wow. And you know what I would have done if they had asked me to go down 5 units? Leave a comment with your answer to that. Okay, now I'm just going to combine these numbers here. Obviously, I have 5 and then a fraction. I mean, hopefully you're not freaking out too much right now. We just need to get these into common denominator, right? So the 5 is kind of like saying 5 over 1. I need this to be in a fraction of something over 6, so I'm going to multiply both these things by 6. So I'm going to end up with y equals, I'm going to rewrite everything, minus 13 over 6. 6 times 5 is 30, 6 times 1 is 6. So I'm going to end up with plus 30 over 6. And now I can add them together. Notice I'm like writing all these steps out. I'm not just doing that so that you can see everything I'm doing. That is merely a benefit of me writing out all the steps. It's merely a side benefit. I'm writing out all the steps because it makes it less likely for me to make a mistake. Okay? That's what you should be doing. I'm always getting resistance from my students who don't want to write out their steps because, oh, they're so smart. They can do it in their head. They don't need to write out all those steps. I mean, this isn't like one of those homework assignments where the teacher asks you to show your work. So all they need to see is the answer, the SAT people, right? So I don't see why I need to write out all the steps. You know, your teacher wasn't just asking you to show all your work just to add more pain to your life. That was just a side benefit. They were doing that because having that habit makes it less likely for you to make a mistake. And it means that if you do end up making a mistake, getting an answer that doesn't seem right, it's easier for you to retrace your steps if the steps are written out. And hey, if you're already getting an 800 on the math, I'll shut up. If you're getting an 800 on the math and you're all good, I'll shut up. But if you keep making these silly mistakes and you're just not sure why and you can't get your score up and you're not writing out all your steps, well, hey. Okay, so now we have our equation here. This is the new line, the Well, I don't know if it's a new line. It's a moved line. Maybe that's why they use these words translated. Is this a new line? Question for the philosophers. It certainly is the resulting graph. Okay, I guess I see the appeal of these weird kind of word choices they have on these questions. Anyways, point is, here's our new equation. We want the x-intercept. Now, before we do that, I would just like to acknowledge, and I want you to acknowledge as well and appreciate how easy a certain mistake would be to make here. You see where I'm going with this? What mistake do you think I'm talking about that would be so easy to do here? Oh, x-intercept. So I'll plug in 0 for x, get rid of that, and I'll have 17 over 6. That's my answer. That's the y-intercept. Okay? The y-intercept is when x is 0. The x-intercept, well, that's when y is 0, okay? They're switched like that. Now, hey, I'm sure you know that. I'm sure you're so smart and know that and would never make a mistake like this ever. But look, just doing one SAT problem when you're scrolling through YouTube or watching someone do an SAT problem as you're scrolling through YouTube, you're in a much more comfortable state of mind. What I would like you to imagine is going through an entire test, the reading section, the writing section, most of the math section, your brains being twisted in different directions, trying to decipher their weird ways of wording things, these math sections. You are going to become more capable of making certain mistakes than you are out there in the safe, real world. Real world meaning math class, or doing your math homework or something, or scrolling through YouTube. So I just want you to appreciate that it becomes easier to make mistakes on the SAT. So that's why it's so important we have these practices in place, like writing out the steps. And I want you to have a little mental checklist of things that are easy to mix up. Like, for example, x and f of x are easy to mix up. Area and perimeter are easy to mix up. Feet and inches, easy to forget to convert. So when there's easy mix-ups like that, and you recognize you're in a problem that asks about one of them, like x-intercepts and y-intercepts, for example, you should be thinking, oh, this is a problem that has an easy mix-up in it. So I need to double check that at the end and make sure I haven't easy mixed them up, okay? X-intercept means y equals 0. So I'm going to replace the y with 0 over here. 0 equals 76x plus 17 over 6. And now I just got to solve for x. I'm going to subtract the 17 over 6 over and get negative 17 over 6 equals 7 over 6x. Now, to get x by itself, what we could do is multiply both sides by the reciprocal of this fraction, right? I could multiply both sides by 6 over 7, and that'd be fine. But since I'm an adult, I'm going to notice that, oh, both sides have the same denominator. Both sides have a 6 there. So we're just going to cancel those both out and just focus on negative 17 equals 7x. I'm going to go ahead and divide both sides by 7 to get x by itself. We end up with x equals negative 17 over 7. So that's great.